moving on to more applications of systems. So last week we just labeled the variables and wrote down what the system was. Now we're going to solve them. So what's important is picking out the key points. So this particular problem, at a particular restaurant, each mozzarella stick has 90 calories, and each pizza roll has 80 calories. A combination meal with mozzarella sticks and pizza rolls is shown to have a total of 1,470 calories. There are 5 more mozzarella sticks than pizza rolls. So when I think about 2 possible equations, I'm going to use the variables M and P for mozzarella sticks and pizza rolls. So there's 90M, that's 90 calories, and 80 per pizza roll. The total was 1470. Okay, so there's one equation. Then I'm going to use the fact that there are 5 more mozzarella sticks than a pizza roll. So the mozzarella sticks is going to equal the pizza rolls plus 5. Now I have an equation I can solve by substitution. I can take that and put it in there. So you got to distribute. Combine the like terms. Move that 450 to the other side. And then divide by 170. So that means pizza rolls is 6. So then I put 6 back up in here, and I get mozzarella sticks is 11. So 6 pizza, 11 mozzarella. Oh, ran out of room. Okay, let's do another one. Lillian and Jacob work at a dry cleaners. Lillian can iron 25 shirts per hour. Jacob can do 20 shirts per hour. In total, in an hour, they can do 295. No, they worked a combined 13 hours and iron 295 shirts. So the combination of Lillian plus Jacob is 13 hours. And we have 25 per hour for Lillian and 20 per hour for Jacob. 295 hours total. So now I could solve by substitution. I could multiply the top equation by negative 25 or negative 20. I think I'm going to just do substitution. So if I subtract L here, I have the J's equals 13 minus L, and then I can just put that in there. So I have 25L. Take that times 13 minus L. So then I have that. The tricky part is coming up with the 2 equations and then picking the method you want to use to solve. So I distribute the 20. So that means I have 5L. I'm going to subtract the 260. So then I get 5L equals 35. So then if I divide by 5, Lillian is 7. And then all I have to do is put the 7 in up in here for Lillian, and I get 6 for Jacob. So L is 7, J is 6. Do one more. David went to the grocery store and purchased cans of soup and frozen dinners. Each can of soup has 250 milligrams. So I have cans of soup and frozen dinners. And then the frozen dinner is 550 milligrams. David purchased a total of 13. The total milligrams of sodium was 4,450. So I know that I have 250 milligrams of sodium in a can of soup, so 250 C, 550 in a frozen dinner, 550 F, total of 4,450 milligrams. And then I know that I have 13 total items. So I'm going to solve for F and do the substitution, which is going to give me 250 C, 550, 13 minus C equals 4,450. And then it's just the algebra. Distribute the 550. Oops, that's 7150. Okay, that's supposed to be a 1 there. Then what I have is negative 300 C. I'm going to subtract that 7150. Combine those two. Equals negative 2700. So then I have to divide by negative 300. So C is going to be 9. So if C is 9 and F is 13 minus 9, remember, because F was 13 minus C, so that's 13 minus 9. So that's going to be 4. All right, so the assignment is in Delta Math. It's the second applications of systems, number 2. What is this puzzle? The writing is on the wall. Please reach out if you need anything.